Hi, we're here again to talk more about duct fittings, and today we're going to look at the transition. And a transition is a duct fitting which changes. Okay, so we'll see those a lot on main trunk line of a duct system, where we're reducing that trunk size down. And here's an example of one. Okay, this is a two-piece transition, same as what we're going to draw here. They can be made typically in 2, 3, or 4 pieces, depending on how complex they are. So we're starting at the simplest one, a 2-piece, with one side sloped. Okay, so you can see that one. Small end here, large end. The width is staying consistent through the whole fitting. So that's our sample. We have our shop drawing on the board here. We're 6x4 transitioning down to 4x4 over a length of 8 inches. Now again, our 6 is here, and then we go down to 4 over here. So that gives us, if we looked at it as a straight piece of duct kinda, we got a 2-inch slope here, going from 6 to 4, and it's over a length of 8 inches. So we got 2 legs of a triangle. We can calculate out that hypotenuse if need be, which we'll need for that top piece. That will be our small piece, or the top, whichever we want to refer to it. So these are bends here. We'll make those in one piece, a U-shaped piece. And then the top, we can see the seams on that one. So when we first look at a transition, we have to decipher how many pieces it's made out of. Now, even though we call them 2, 3, or 4 piece transitions, they can all be made out of one piece. We can bend it up, but the way that it starts forming up like a conical sort of, it's not worth the effort to lay it out that way. It's a waste of material, it's a waste of time, etc. So when we refer to them as 2, 3, or 4, it's more about the efficiency or the proper ways, the best practice on how to build them, not that it's impossible to make them out of one piece. So we look at our numbers on both sides. We look inside the fitting here. If there's any indications, we'll see different down 2 inches. We might see some sort of indication of what's happening inside here. Okay, we might see FOT or FOB, flat on top or flat on bottom. We don't have any of those. Those are just some examples, but in this case we don't have any. It's not telling us anything except it's transitioning from 6 to 4. When we look at our depth, our second number, it stays the same. So that we know that depth is equal the whole way. We might have had this side sloping somehow, right? And we can't see that in this view, but this is what tells us in conjunction with nothing written in here. So we know this will be a 2-piece transition. And we know that it's going to be made up of a U-shaped piece, like that, and a top. So we'll call that the body and the top for our purposes. For this example, the body and the top. Okay? So, like always, our first step is to do some blank sizes and figure out what the piece is we need to accommodate this part. So we know we're a length of 8. That's not going to change. That's going to be our second dimension of our blank. Remember, our 6 is here. Okay, so if I go up to our little drawing here, I know that it's coming 6 here and going across 4. And then coming up another 6 here. So 6, 4, and 6. And that's going to be our shape. It's going to go 6, out 4, and then back up 6. So that's going to be our, if we find our perimeter of this, or again our stretch out, 6 plus 4 is 10, plus 6 is 16. And the length at 8 inches. That's our body. For the top, we know that it has to be 4 inches wide here, right? Because this has to be 4. So I'm just going to jot in the 4. But it's the length of the part that we're unsure of right now. We know that it's going the 8 across. And we said that we had that triangle in there, and I can do it on the inside here as well. Same triangle. I know it's 2 here and 8 here. So we can use Pythagoras as a squared plus b squared equals c squared. And we want the square root of c to find out what the actual length is of this part here. So let's punch that in. Let's fill in some of our blanks here. And if I take a out of there, let's call a 2, and b we'll call 8 for our example. We get 2 squared plus 8 squared equals square root equals 8 1/4. And then we take the root of this, remember? Because we want c on its own. We don't want we would want c squared. So this distance here equals 8 1/4 on the slope. So it's grown a little bit. And we have to take that into account, of course, or we would be short. Okay, so for our blanks, we finish off at 8 1/4 by 4 inches. So we have the length of it, which is grown compared to the body, and then our width at 4. Okay? So let me clean this off a little bit, and then we'll draw up our blanks. Okay, I've drawn got my blanks drawn out now. I've got the body at 16 by 8, and the top at 8 1/4 by 4. And if we draw in our arrow for airflow, I'm going this way on both, traveling through the fitting this way, of course. Now you'll see that the top is longer, right? We knew that the 8 1/4 and the 8 are what matches here as the length. So that's the direction, and that's correct that they're not the same. Because this one, remember, the top is on the slope, it has to be longer. The top has no layout to it, it's done. It's just a flat piece of metal, so we're done there. We don't have any layout, but we do on the body here. So let's start with the layout of that. And this one is very similar to doing a piece of duct. We're thinking of perimeter. We know we made this one the U-shaped piece. So what we want to do is establish the perimeter that we calculated to get the blank size or the stretch out, and we're going to mark that out. So we went 6, then 4, then 6. So let's mark that. So I come across, I go 6. Now you can come from the side here and then do the same this way. And then we always want to double check the center to make sure that it's true. And then I'll bring those lines down. So now I got 6, 4, 6. I got my perimeter laid out. And it's the same down here. 6, 4, 6. Okay, so far so good. Now when I lay out, we want to lay out the transition now, and we know that we're going from 6 inches down to 4. I like to do that transition at the top edge, but really it doesn't matter. You're going to do it to one end, because we know one end shrinks down to the 4 inches. Now we need to be based off these lines here, which are our bend lines, which is this here. And I know that from that bend line I came out 6 on this side, and from that bend line I came out 4. Now you could say, why don't we just measure the 2 inches here? And you can. It's not to say that you can't, but remember that the most important, the most critical feature of the fitting is the opening. So I always recommend measuring the opening, which is our 4 inches. So I'm going to take from my bend and come out this way 4 inches, and I'm going to come out this way 4 inches. And I get those down there. So now I've changed that. I'm 4 here. I'm 6 here. Which should, we're correct, it should leave us 2 inches down here. So now I just join corner from the outside down, the 6-inch corner up to my 4-inch mark on both sides. And that's our layout complete. Let me just remove some of this line work in here just to clean it up so it's visually clean. Okay, so we've transitioned now. We got 6, 4, 6 at this end, and we have 4, 4, 4 at this end. These corners will be sheared off. And if we measured now the black slope line here, that should now match our 8 1/4 or whatever the top was calculated at. This slope line now needs to equal the length of the top, okay, for them to match up. Okay, 2-piece transition.